In section 2.3, we're going to continue to solve inequalities, this time using multiplication or division. So let's take a look at example 1. Example 1 says solve and graph the solution, and we are given the inequality x over 8 is greater than negative 5. X divided by 8 is greater than negative 5. If I'm going to solve this, I have to get the x by itself, which means I have to do the inverse of division, which is multiplication. So I'm going to multiply this side by 8, forcing those 8s to cancel, and then I'll multiply the other side by 8, which means I'll end up with x is greater than negative 40. X is by itself, so my inequality is solved. Now I have to graph this. Just like we've been doing in the other lessons, I'll put negative 40 in the middle, and then I'll count up. Up would be negative 39. I'll count up from negative 40. And I'll count down from negative 40. And then I'll go ahead and put my dot, because it's greater than and not greater than or equal to, it should be an open circle. And since we're talking about greater than, the arrow should go to the right. So let's try the next one. Same thing or similar. I want to get the x by itself. I do notice that the x is not in front, but that's fine. To get the x by itself, I need to get rid of that 3. I'll do that by dividing both sides by 3. And I'll get negative 8 is greater than or equal to x. I always want my variable to be first. I want my variable to be in the front, so I'll write that first. X is less than or equal to negative 8. Now that I have my inequality solved and my variable in front, I can graph it. I can put negative 8 in the middle and count up from there, just like we've been doing, and down from there. I'll put a closed circle at negative 8 because it's less than or equal to. Remember, it's the equal to part. So just as a quick side note here, or reminder, if it's greater than or equal to or less than or equal to, it's a closed circle. If it's just greater than or just less than, it's an open circle. Okay, so this is just kind of a little reminder here. And then I'm talking about less than or equal to. Remember, as long as my variable's in the front, my inequality is going to point the direction my arrow should go. My inequality is pointing left, so my arrow should go to the left. Let's keep doing that same thing. In example C, I have my x in front, so that's good, but I have to get rid of the 4. I'll get rid of the 4 by dividing both sides by 4. And I'll divide by 4 here. I'll get x is greater than or equal to 9. The x is in the front, so we're good to go. I'll put 9 in the middle of my number line and count up and down from 9. It should be a closed circle at 9 with an arrow to the right. One last one before we kind of switch gears here. The next one is kind of like the first one. I need to get the r by itself. I'll do that by getting rid of the 7 by multiplying by 7 on both sides. We'll get r is less than negative 7. I'll put negative 7 on my number line and count up and down from there. Should be an open circle at negative 7 with an arrow to the left. There's one thing we need to talk about when we're solving using multiplication and division, and that's the core concept, multiplying or dividing by negative numbers. So when we're multiplying or dividing by positive numbers, nothing is different. It's the same as it is with solving equations, and everything is fine. When we're multiplying or dividing by a negative number, so whenever you multiply or divide by a negative number, you actually have to flip the inequality symbol. So let's write that down. When multiplying or dividing by a negative number, you flip, I'm going to write it in all caps and underline it, the inequality symbol. So anytime that you multiply or divide by a negative number in your equation or in your inequality, you have to flip the symbol. So let's try this out several times so we know. So let's start by solving this, okay? I need to get the y by itself. In order to get the y by itself, I'm going to have to get rid of that divided by -3. Well, we learned back in chapter 1 that to get rid of divided by -3, we have to multiply by -3 on both sides. So I want to multiply by -3 to cancel that, which means I have to multiply by -3 on this side. Because I am multiplying, I'm going to write this down. Because I'd multiplied by a negative, I have to flip the inequality. So when I write this as -6, I have to flip the inequality. I'm actually switching the inequality. And then I have y over here, okay? So that's a really important step that we can't forget. If we multiply or divide by a negative, we have to flip the inequality. Now this one's not done actually because I want my variable to be on the other side. So I'm going to rewrite it so that my variable is on the other side. So I end up with y is less than -6. I'll put -6 on my number line. I'll label everything to the left and right of that. And then we can graph it, okay? So the really only difference here than solving it just like we did in example 1 is that I had to flip the symbol right here because I multiplied by a negative, because this was -3. If this was just 3, I wouldn't have to switch the symbol, okay? And then we flipped everything here, but that was just to get the variable on the correct side. So this flip was because we multiplied by a negative. Let's go ahead and put an open circle at 6. We're looking for anything y is less than -6, so that's an arrow to the left. Let's try another one of those. If I'm going to get this y by itself, I'm going to divide by -7. So I'll divide by -7 on both sides, and I'll get y is less than or equal to 5. Oop, I missed something. Oh my gosh. Let's go back here. I divided by a negative, right? I divided by -7, so I have to flip my symbol. So it should be y is greater than or equal to 5. Don't forget that. I almost forgot it. Whenever we multiply or divide by a negative, we have to flip the symbol. So because I divided by -7, this symbol flipped. And my answer is now y is greater than or equal to 5. So I'll put 5 on my number line. I'll count up and down from 5, and I'll put a closed circle at 5 with an arrow to the right because it says greater than or equal to. I'm going to repeat it again and probably like 16 more times. If you multiply or divide by a negative, you can't forget to switch the sign. Okay, so let's move to the next page. We're going to keep practicing these. So I need to get x by itself here in example C. If I'm going to get x by itself, I have to undo whatever's next to x. I have to undo the times, because this is multiplication. I have to undo the times -3. I'll do that by dividing by -3. Make a quick note in your head. I just divided by a negative. The first thing I'm going to do, so I don't forget, is I'm going to switch the symbol. Before I do anything else, I'm going to switch the symbol. And now I'll do the rest of the solving. The -3 cancel, and that's just x. 15 divided by -3 is -5. I do want to switch this to get my variable on the in the front, so I'll change it to x is greater than -5. And then I can graph this. I'll put -5 on my number line and label everything to the left and right of that. I'll put an open circle at -5 because it's greater than, not greater than or equal to. And greater than is to the right. Anything greater than -5 is over here, so my arrow will go there. So again, I'm going to say it once more. Don't forget to switch that symbol because we divided by a negative. In the next one, we're going to multiply by a negative. So I see that there's a divided by 4 here. Well, that negative can go on the top or the bottom. I'm going to add it kind of just with the 4. So really, you don't have to rewrite it if you don't want to, but I'm going to rewrite this as x over -4 is greater than or equal to 2. I'll solve this then by multiplying by -4 on both sides. Because I multiplied by a negative, I need to switch my symbol. And I'll be left with x is less than or equal to -8. Let's go ahead and solve or graph that. We'll put -8 there. Make sure you're labeling your number line. Careful with the negatives as you watch me label these. Remember, things to the left are more negative. Things to the right are less negative. I'll go ahead and put a closed circle at -8. We're talking about less than, so that means an arrow to the left. Let's go ahead and write an inequality and then solve it for this next example. So it says you earn $9.50 per hour at your summer job. Write and solve an inequality that represents the number of hours you need to work to buy a digital camera that costs $247. So what am I trying to solve for here? Write an inequality to represent the number of hours. Number of hours is what I'm trying to solve for. So I'm going to name a variable h. H is going to stand for the number of hours. Okay? I want to know how many hours do I have to work. Okay? Well, I know something about every hour I work. I make $9.50 per hour. So every hour I work is $9.50. I can represent that mathematically with the expression 9.50 h. I make $9.50 per hour. For every hour, I make $9.50. I need all of that to be more than or equal to, in other words, greater than or equal to $247 so I can buy my camera. Okay, I need to either make exactly $247 or more. So I'm going to use the greater than or equal to symbol, 247. So there's my inequality. I need to solve this by dividing by 9.50 on both sides. I'm not dividing by a negative, so I don't switch the symbol, so I'll leave it as h is greater than or equal to. And I'll calculate 247 divided by 9.5. That's 26. I'll go ahead and label this 26 hours. So I need to work greater than or equal to, more than or equal to 26 hours. So that is solving inequalities using multiplication or division. It's very similar to solving equations. The big difference is when you multiply or divide by a negative, you have to remember to switch the sign. That's the biggest thing that I want you to take away from this section. So that's it for 2.3, solving inequalities using multiplication or division.